pretty much it, and I can resize it. And you can see it kind of looks a little weird, but it mostly keeps its shape. That's because of the way I'm pulling samples from the compare it to this here map, and then graphics, which is for drawing on. Then I want to define storage as a new list of short, and short is a signed 16-bit integer, and then it opens the file dialog. And upon the open it onto the picture box by using this command, picture box one image equals pic. There we are, simple enough. So when you click on the picture box, it opens the file dialog, and upon the open file dialog being okay, which you can create that easily enough by just double clicking on open file dialog, then I should say something else real quick about that. Open file dialog, when you dump an open file dialog in, it puts in file name as open file dialog 1. You want to take that out because I actually use that later, so you want to clear that first. Anyways, getting back to this. First thing we want to do is actually read that file into bytes, and I have this as kind of an example from another video I've made where you bytes from. What a binary reader allows me to do is actually take those binary chunks of data and put them into the types that they were originally intended to be easily. So there's two websites I want to show you here. One's from Stanford, and the other one's from, what's it called, Sonic Spot. So I'll put these links in the description for these two websites. But it shows you what the header of the WAV file looks like, and then the data that comes after that. So I'm taking all these header pieces and their sizes here, and I'm breaking them out into each individual things. And once I read it, it actually clears it from the binary reader. So if I read an int32, it's going to shift everything up, FMT and T data, for a starting reference. So I guess not really part of is the draw audio case of that. This one, because the audio is actually
Bye.